when we determine the equation from a given trig graph, we basically use the general form of a trig function and just fill in the blanks as we go along. There's a whole heap of instructions here, but I think the best bet is to just give it a go first of all and see how it goes. All right, so the first move I do is I go, all right, this looks pretty much like a sine graph. So I'm going to go y equals, and I'm going to start with sine. Okay, now I can see that it hasn't been translated vertically, so the mean line is 0, so it's going to have a plus 0 on the end, or no vertical translation. It's got an amplitude of, I can see clearly 2, so it's going to be 2 sine. And all I need to do now is match up the period. Now the period of this function here is 3 pi. Now what that means is that we need to note that the standard period of sine is 2 pi. Now I need to make the standard period, so that would be if it was sine x, I need to make that 3 pi. Now what do I do? Well, what I would do is go 2 pi over an n value gives us a period of 3 pi. What's the n value? That's going to be n, so 2 pi equals n times 3 pi. N equals 2 pi over 3 pi. Cancel those out. N is equal to 2/3. So that means that I've got my value of 2/3 for n right there. Now, and plus 0. And you can just quickly check this as well by going, all right, period of a standard sine is 2 pi over the n value, which is 2 pi on 3, which is going to be 6 pi on 2, which is 3 pi, which matches up perfectly. Okay, so that's our first equation there that matches, that particular graph. All right, so have a look at this one. Okay, so the way I think about this one is I think that this looks mostly like an inverted cosine. So standard cosine looks like that. So the inverted cosine will look like that. Okay, so I'm going to go an inverted cosine. I'm noting that the mean line is 0, so I'm going to go cosine. This is going to be a negative. What's the amplitude? It's 3, so y equals -3 cosine. And what's my period? Well, it looks to be 4 pi on 3 gives us 1 full cycle. So we're going to go and do the same thing, which is 2 pi over an n value gives us a period of 4 pi on 3. What's the n value? So it's going to be 2 pi over 4 pi on 3 gives us the n value, which is 2 pi times 3 pi, 3 over 4 pi. Those cancel out, and that gives us 2 3s are 6, 6 on 4 is 3 on 2. So n equals 3 on 2. So 3x on 2. Right, so there's our trig function. Again, you can quickly check the period. So we'll go 2 pi over 3 over 2 equals 4 pi on 3, which checks out with that. So we've got that one right. All right, let's have a look at this one. So this also looks like an inverted cosine graph. Okay, so what we're going to do is start with that. So it's y equals, and it's negative, and it's cosine. Now, what's the amplitude? Well, it's 3 and -1, which means that it has to have undergone a vertical translation. So what's happened is the mean line now is at 1. So this is going to be cosine something plus 1. And we can see there that it goes 2 up from the mean line, 2 down from the mean line, so it's 2. All right, so it's x, and we can see that 1 full cycle happens between 0 and pi, so it's 2 pi on n gives us a period of pi. That means n is equal to 2, so we've got our function now. All right, last one here is this trig function that is tan. So what we've got is tan, so let's go y equals tan. Now I can see that what's happened is that it's undergone 2 separate things. So I can see that that anchor point is usually at 0, 0. And what's happened is, so that's the way tan usually behaves. It starts at 0, 0, so tan x will always start there. This one has moved across pi on 4 and gone up 1 unit. Okay, so what has happened is that the tan graph has moved across Okay, so we're going to go and move it right, pi on 4, and it has gone up 1 unit. Now, we don't know about a dilation factor yet, so we're not going to worry about that just for the moment. All right, what we need to also be aware of is that tan typically has a period of pi. This one here has got a period of, what is it? It's 3 pi on 4, take away negative pi on 4, which is 3 pi on 4 plus pi on 4, which is 4 pi on 4, which is pi. So this actually hasn't been dilated at all. So we're safe in writing x over here, knowing that the period is going to be pi over 1, which is just pi. So it's only been the translation. All right, now has it been dilated? So this a value here will tell us whether it's been dilated. And to do that, all we'll do is we'll just choose a point to check the value of a. So I'm going to choose, for argument's sake, this point here, which is pi, comma, 0. You can choose any point you want. In fact, I could choose 0, 0. Okay, and it will work nicely. But anyway, let's just choose this one because I've already committed to it and I don't want to re-record this video. So we're going to go y equals 0, a tan pi on, what was it, pi? Yep, take away pi on 4. So that's 4 pi on 4, take away pi on 4 plus 1. 0 equals a tan 3 pi on 4 plus 1. Now the tan of 3 pi on 4, here we are, we've got negative 1. So that's going to be negative 1. So 0 equals negative 1a plus 1. Negative 1 equals negative a equals 1. So actually, there's no dilation factor. So a is equal to 1. I'd certainly, if I wrote a test question on this, I'd make a dilation factor because the default is 1. If you guys forget to use a, that means you're going to get this question right, and we can't have that. All right. So I would certainly whack a dilation factor in there if I was to do that of like 2 or 3 or something. All right, so our function therefore is tan, so our a value is 1, so we can just write it in as tan, x take pi on 4 plus 1. All right, so there is a worksheet and another worksheet there that I'll make sure I upload to Firefly. So check out Firefly for those.